Hi, I'm Dr. Tim Komar. In this video, we will show an example of integration by substitution that requires a little extra algebra in addition to the substitution rule. This video is appropriate for those in first or second semester calculus courses and AP calculus courses. So the substitution rule: if u is a differentiable function g of x, whose range is an interval I, and f is a continuous function on I, then we have that these two integrals are equal. And the basic idea here is that if we make the substitution where u is g of x, we end up with a simpler integral to compute. So the example we're going to look at today is we want to compute the indefinite integral of x cubed times the square root of x squared plus 1. So again, in general, the goal is to undo the chain rule. So to do this, we're first going to identify an inside function and a composite function. And here, the inside function is simply going to be that x squared plus 1 that is inside the square root expression there. So now to write the integral in terms of the new variable u, we also need to find the relationship between the differentials du and dx. So by computing differentials, we are going to obtain as follows here. So du is just the derivative of u times dx. And remember that u was x squared plus 1, so du is simply going to be 2x dx. And again, since we did not have a coefficient of 2 in our original integral, we're just going to divide through to make things a little more convenient. So 1/2 du is just x dx. We can now partially rewrite the integral in terms of u, and we have it here in a color-coded manner. First little thing we're going to do is we're going to factor the x cubed into x times x squared. Why? Because we're going to recognize that x dx is the 1/2 du that we computed on the previous slide, and the x squared plus 1 is just u over here. The remaining question is how to represent that factor of x squared in terms of u. Well, very simply, since u is x squared plus 1, x squared is u minus 1. So we can now finish rewriting the integral in terms of u and compute. So here now, that last step, we're going to, in place of x squared, write u minus 1. And then we're going to multiply the u minus 1 times the square root of u, write things in terms of powers here. We're going to get u to the 3/2 minus u to the 1/2 power here. We're going to then compute the antiderivatives of these two terms using power rule, and we end up with the following in terms of u, and then we are going to substitute back x squared plus 1 in for u in both these two places over here. And don't forget, as this is an indefinite integral, we need to add the constant of integration c here. Again, I'm Tim Komar. I'm available for mathematics tutoring for all high school and college math courses, and look forward to hearing from you. Thank you.